Okay, so in this video, I'm going to show an example of a problem involving probabilities under normal distribution. The problem states that daily allowance in a certain school is assumed to be normally distributed with a mean of 200 pesos and a standard deviation of 50 pesos. The question is, if a student is randomly selected from that school, what is the probability that his daily allowance is less than 180 pesos? First, we know that this is a probability question under normal distribution because it states that the daily allowance in that school is assumed to be normally distributed. Without this assumption, we cannot proceed with the probabilities involving normal distribution because in the first place it is not a normal distribution. But since it is explicitly stated that it's normally distributed, then we can now consider this as a probability question under normal distribution. So what do we need to answer a question like this? The first thing that we have to do is to assign a random variable x. So we say let x be the random variable representing the daily allowance of the students. The daily allowance of the students. So that means the probability that we want can be written as the probability that the daily allowance x of a certain student chosen randomly is less than 180 pesos. And this is the probability that we want to find. To find the probability, we need the value of the z. Z is the z-score. And the z can be computed by the formula x minus mu over the standard deviation sigma. So what is our mu and what is our sigma? So we have to go back to the information given in the problem. It says that the mean is 200. So that means that's our mu, and the standard deviation is 50. So from the information, we can see, or we know that the mu is equal to 200 and the standard deviation is equal to 50. So this will help us find the corresponding z. So we have x. Our x here is the concern value, which is 180 pesos. So we put these numbers in the formula and we have 180 minus the mean, 200 divided by the standard deviation 50. And we simply compute for the value of these numbers. So 180 minus 200 over 50 is equal to, this is equal to 0.4 or negative 0.4. Once you have the z, so z now is equal to negative 0.4, you need to find the corresponding probability under the z table. So in the z table, so make sure you have the copy of the z table. You have to select the one that is the negative version. So to locate the corresponding probability, you need to find where is 0.4 in the first column, and then since there is no added number here, it means it's 0. So on the first row, you have to locate the 0.00. So you have the 0.4 and the 0.00. Then identify the corresponding decimal value which is the intersection of these two numbers. So 0.4 on the row and 0.00 in the column, that will give you a value of 0.00. 0.3446. Okay. Most z-tables follows an area to the left. Now, since the probability that we want is the probability that x is less than 180, the less than indicates that we have to find the area to the left. So since we already have 0.3446 as the area to the left, then the probability that the allowance of that student, randomly selected student, is less than 180 is 0.3446 or 34.46%. So there is a 34.46% chance that that student has daily allowance less than 180. Now, to give you a follow-up question, if the question was, or if there is another question asking you for the probability that the daily allowance of another randomly selected student is greater than 180, and since we follow a z-table with an area to the left, then that means to get the probability of a greater that is to the right, we need to perform 1 minus the probability of x less than 180. So that means since the probability that x is less than 180 is 0.3446, the probability of x being greater than 180 is 1 minus 0.3446. And this will be equal to 0.6554. So the probability that the daily allowance of a randomly selected student to be greater than 180 is, this is equal to 65.54%. Okay, so let's summarize what we have done to compute for a certain probability. First and foremost, again, before we perform this procedure or process, we need to make sure that the distribution is a normal distribution. And then you have to set a random variable to represent the values that we are or that is being talked about in this problem, and that is on the daily allowance of the students. Then initially set up the symbol of the probability that we want to find, and that is a probability of x less than 180, and then find the corresponding z-score for that x equals 180. There is a formula to use in finding the z-score, and that is z equals x minus mu over the sigma. Perform the calculation until you get the necessary or the needed value, and in this example we found it to be negative 0.04. Use the z-table to find the area that corresponds to negative 0.04, 0.4 rather, and make sure that you're using the negative z-table because there are two versions, the negative and the positive. You use the negative when the z is negative, and you use the positive when the z is positive. The value that you will get by locating the intersection of those two numbers will be the probability that we want. By default, the probability given to you there is the area or the probability to the left. The area to the left, that's the probability. That's why I asked or I gave another follow-up question that suppose that we are concerned about getting the probability being greater than a certain number. That means we want to find the area to the right. And to get the area to the right, we subtract the area to the left from 1. Whatever the value, that is the area greater than or the area to the right. Okay, so I hope you understand now how to find the probability involving normal distribution. In the other examples that I'll be showing you, we'll be talking about the probabilities involving sampling distribution. And sampling distribution is related to normal distribution. However, there will be some slight difference or differences in terms of the formulas that we have to use when it is already under sampling distribution. So keep in mind that this example is purely on a normal distribution without getting a sample. This is just getting a specific in this case a specific student, or if it's a set of objects, we are just getting a single object. Okay, so again, I hope you understand now the concept of probabilities involving normal distribution.